So now the question is, does this also work for really huge triple stores where you have 1 billion triples? And what we do here is we compare Allegro Graph 3.2 against another triple store. I can say it's Al-Lim. And what you see is that the total query time for Allegro Graph 3.2 is faster. Well, what does this consist of, this performance gain? Well, again, we see that in query 9 we get a really big improvement with respect to the other database. And for the intermediate ones, we're roughly the same. So let's get rid of query. Oh, let's look at the small ones, and you see that even for the very small ones, Allegro Graph is now blue. We're kind of faster for all the queries. So we now get into the same range as the triple stores that do materialize, and for us that's a big deal because, as I said before, most of our customers want dynamic triple stores where you can keep on adding data and you get good performance. If you look in general at all the triple stores, just to give you a statistic, is usually what you see is you load your data, and it takes some time. So if you load 1 billion triples, for other triple stores, a single CPU, it might take more than a day. But then you also would have to wait hours and hours and hours before you do your full type materialization. And then query time is almost nothing compared to load times. So here we give you the data for another database, for Allegro Graph on the single CPU, and Allegro Graph on federated. So with 3.2 we're much more dynamic. You can add a few triples, delete or change the whole ontology, and then you're back into doing queries within a few minutes. So it still does take a few minutes because we build up some dynamic indices now on the fly, and you can decide after loading the triples to rebuild all these new indices at one time, or you cannot do it, and then when you do the queries, these new indices will be built on the fly. And you get a little bit of a performance hit if you hit some particular new predicate for the first time.